There is a pigeon outside almost every window in the world right now. On a ledge, on a wire, pecking at something on the pavement with the focused indifference of an animal that has never been impressed by anything. You have probably looked at one and thought nothing in particular. Here is what you should have been thinking. That animal is a dinosaur. Not metaphorically. Not in the loose, poetic sense that everything alive today is descended from something ancient. In the precise, technical, biological sense that paleontologists have been trying to communicate for 30 years and popular culture has almost entirely failed to absorb. The pigeon on the ledge is not a distant relative of the dinosaurs. It is not an animal that evolved from dinosaurs the way mammals evolved from earlier mammals. It is, by every definition currently used in taxonomy, a dinosaur, a living one, looking at your window. The question that follows from that is obvious and strange, and nobody has a clean answer to it. The obvious question is whether birds are smart enough to understand their own evolutionary history. Which is, of course, not a real question. No animal understands its own evolutionary history, including us in any deep experiential sense. We know it intellectually. We don't feel it. But that's not the right question. The better question is, what does it mean for an animal to carry something it has no access to? The pigeon on your ledge has a wishbone, the furcula, that is structurally identical to the one found in velociraptor fossils. It has hollow bones, a four-chambered heart, and a reproductive system that produces hard-shelled eggs using the same biological machinery that produced dinosaur eggs 150 million years ago. All of that is still there, still running, still doing exactly what it was designed to do, in a body that has no idea what it inherited. What does it mean to be something you can't know you are? In 1996, paleontologist Phil Curry and his team working at sites in Liaoning Province, China, began uncovering something that would permanently change how science understood the dinosaur-bird connection. Fossils of small theropod dinosaurs, animals like Sinosauropteryx and later Microraptor, preserve not just bones but the impressions of filamentous structures around them, proto-feathers, not scales, not bare skin. The beginning of the same structures that today keep a sparrow warm in January. The find confirmed what some researchers had suspected since the 1970s, but couldn't prove. Feathers did not evolve for flight. They were already there, for insulation and display, millions of years before any dinosaur left the ground. Flight was a later application of a structure that already existed for completely different reasons. Then, in 2010, a study published in Science by Xing Xu and colleagues formally reclassified the evolutionary tree in a way that made the connection impossible to ignore. Birds are not descended from dinosaurs. Birds are dinosaurs, specifically avian theropods, a subgroup of the same clade that includes the T-Rex and the velociraptor. The branch didn't end. It narrowed and kept going and is currently sitting on your window ledge. Start with what birds actually retained. The wishbone present in every bird alive today is a fused clavicle. The same structure appears in fossilized theropods going back 150 million years. When a chicken stretches its wings before a sprint, it is using a mechanism that was already fully developed in animals that lived alongside the T-Rex. Now, think about behavior. Cassowaries, large, flightless birds native to New Guinea and northern Australia, have a reputation among wildlife biologists as genuinely dangerous animals. They stand up to 1.8 meters tall, weigh up to 60 kilograms, and have a dagger-like claw on each foot that can reach 12 centimeters in length. When researchers study cassowary attack patterns, the descriptions are specific. The animal assesses, waits, and strikes at the abdomen, not a panic response, a targeted, efficient attack pattern. Biologists who work with both cassowaries and crocodilians, the other living archosaur lineage, note a behavioral similarity that goes beyond coincidence. Something in the threat response architecture is conserved. Something that was already working in the Mesozoic is still working now. But here's what's really interesting. In 2020, a study in Nature Communications analyzed the brain development of modern birds and found that the expansion of the pallium, the region responsible for complex cognition, problem-solving, and what researchers cautiously call awareness, happened independently in birds and mammals, following different neural architectures to arrive at similar functional outcomes. Birds don't think the way mammals think, but some of them demonstrably think. Crows recognize individual human faces and hold grudges across years. African gray parrots understand the concept of zero. Pigeons can distinguish between Monet and Picasso with accuracy that exceeds chance. The dinosaur on your window ledge is not running ancient simple software. It has been running and updating that software for 66 million years since the asteroid. It is, in several measurable ways, more cognitively sophisticated than most of the dinosaurs that came before it. But here's the thing. The question we started with, do birds know they're dinosaurs, was never really about birds. It was about what it means to carry an identity you have no access to. Every human alive is a primate, a mammal, an animal that, 300 million years ago, shared a common ancestor with the lizard on the wall. We know that. We can say it. But we don't experience it. It doesn't change how Tuesday feels. The pigeon doesn't know it's a dinosaur for the same reason you don't feel like a fish. The knowledge requires a distance from experience that living inside a body doesn't allow. What the bird carries, it carries without knowing it's carrying anything at all. And what it carries, the hollow bones, the wishbone, the four-chambered heart, the hard-shelled egg, has outlasted every other dinosaur lineage by 66 million years and counting. Whatever the dinosaurs were, birds are the version that survived. Not a memory of it, not a symbol of it. The thing itself, still here, still running, completely indifferent to the fact. The next time you see a bird, anywhere you are looking at the only living dinosaur, not a descendant, not a reminder, the actual lineage, unbroken, from the Triassic to this morning. It doesn't know that. It knows whether the seed on the ground is worth the trip, whether the thing moving at the edge of its vision is a threat, whether it is warm enough and fed enough and safe enough to stay where it is. It has been making those calculations in one form or another for 230 million years. It is very good at them.